Hello and welcome to this lecture. In this lecture, let us see what is nanotechnology, its overview, and its scope. So, after going through this lecture, you will get a brief understanding of what is going on in nanotechnology and how it is important for future advancement in technology. So, the nanotechnology it is nothing but a synthesis, design, and application of nanostructures, and it is the study of properties or phenomena with respect to material dimensions. So it's between properties and the material dimensions. So nanotechnology is basically the it is a study of synthesis, design, and applications of nanomaterials. So basically, nanotechnology it, studies the materials of dimensions in the range of 1 nanometer to 100 nanometer. So when we take a solid, we have three dimensions. For a particular solid, there will be three dimensions, and so here there are different categories of nanomaterials. So for nanoparticles, in all three dimensions, the size is less than 100 nanometer, or it is in between 1 nanometer and 100 nanometer. Same for nanocrystals and for nanowires in two dimensions, it is less than 100 nanometer. So if you take a nanowire, it will be like this. So only in this dimension, the size is greater than 100 nanometer, but in the other two dimensions, it is less than 100 nanometer. Same goes with nano rods and nano rings. These are also one dimensional nanomaterial because suppose when we take a nano wire and you connect like this, it will become nano ring. So only in this circular direction, the size is greater than 100 nanometer. But if we take the cross section of this, it will be less than 100 nanometer. And we have nano prisms. So nanofilm. So basically, these nanoparticles, these and these are the nanomaterials we call it. Okay. And whereas nanowires and this and the nano rings, these fall under one dimensional nanomaterial. Yeah. And these nanoprisms and nanofilms actually in so only in one dimension it is less than 100 nanometers. Along this it is greater than it can be greater than 100, and along this it can be greater than 100, but in the other direction the height of the film will be less than 100 nanometer. That is, thickness of the film will be in the range of 1 nanometer to 100 nanometers. So it is two dimensional nanometer. Same with the nanoprisms as well. And we have finally 3D nanocrystals. So these are basically three-dimensional nanomaterials. So how these are different? Because these 3D nanocrystals are made from nano structures. These are made of nanostructures. So basically, its size will be greater than 100 nanometer in all three dimensions. But it is it is made up of building blocks which are nano materials. So this is how we can categorize nanomaterials based on the dimensions like 0D, 1D, 2D, and 3D. And so nanotechnology deals with the materials in the range of 1 nanometer to 100 nanometer. And nanomaterials, when we get into that, when we make the material less than 100 nanometer, so basically when we consider a nanomaterial, it has properties different from bulk material. For example, if you look at semiconductors, we know that semiconductors have band gap. But when we um, reduce the size of the material into the nano scale, then its properties change, like band gap. If you look at this figure, for a bulk semiconductor, this is the band gap. And as we decrease the size into the nanoscale, the energy band gap kept on increasing. So here, basically from 6 nanometer to 2 nanometers, the band gap is increasing rapidly with the decrease in size in the nanoscale range. And we see the bands here are continuous, whereas as we reduce the size of the nanomaterial, the bands will be separated with finite energies within this. So this is happens because of quantum confinement. Quantum confinement is one such effect that we can see. So basically, the quantum confinement effect is we are seeing because as we reduce the size of material into nanoscale. So, nanomaterials having these properties, very new properties compared to bulk materials. So, these are highly promising for advancement in technology. So, technological advancement uh, as a nanotechnology has a great scope. With that, we can achieve a great technological advancement with new properties of nanomaterials. And one such application is like we can design using nanostructures, we can design ultra light, ultra strong multifunctional materials. These multifunctional materials. So basically, the material is light, at the same time, it is strong. And there, this has multiple functions in different applications. So the material will be lightweight but strong. So we are achieving both the conditions that we are able to design a strong material at the same time with light lightweight. So the amount of material it takes is lesser. So these are made using nanostructures, and it is also possible with nanomaterials to um, design nanomaterials of having non-conventional properties. Uh, is having like superconductivity and magnetism. These non-conventional properties can be achieved for these materials. So, nanotechnology enables us to design materials of uh, metastable phases, materials with metastable phases. So these materials can be designed using nanostructures which have non-conventional properties like superconductivity and magnetism. So the nanotechnology allows us for the miniaturization of current and measurements. So because of the miniaturization of this current and measurements, like for example, we have a ammeter in a electric circuit lab also where we can measure current. There is a the sensitivity of that instrument has a limitation. For example, 1 milliampere or 1 microampere, below which we cannot measure. But with nanotechnology, it allows miniaturization of these measurements. Like we can be able to measure a slight current, like a picoampere or a nanoampere, etc. And so this is allowing us for the technological advancement. Like for example, um, the computers we are able to design computers with infinite power, which can mimic human behavior. Human brain. It can mimic human brain, uh, and also biosensors, which can detect the onset of disease. These biosensors will detect the onset of disease and also specific target delivery. With nanotechnology, it enables us to send the medicine directly to the diseased cells. So we know that our body had many cells, and the fraction of diseased cells and the size of them will be minute. So nanotechnology, which is in the nano range, can be targeted directly on the diseased cells and uh, can heal that. For example, here we have normal cells as well as diseased tumor cells. So this drug has to be directly hit to the in case of a normal procedure. Normal procedure when we are sending the medicine drug, it is going on to normal cells. When it goes to normal cells, it will affect normal cells and it may partly damage them. But with nanotechnology using targeted drug delivery, we are directly sending on to the tumor cells. So the medicines will act on only the tumor cells and it will heal that. And also we have nano robots which can be called nanobots. These are used to repair the internal damage of cells or tissues. So nano robots will help in that regard. Nanotechnology has potential applications in nanoelectronics, nano-optics, nanobiological systems, and nanomedicine, and other new materials. So as we have different domains here, like electronics, optics, nanobiological system, nanomedicines, it is a multidisciplinary field where it needs part of all the other part of different domains. Like we need a physicist, chemist, material scientist, pharmacologists, molecular biologists. All of these has to work together. These all have to work together for design and synthesis of nanomaterials and for studying the relation between properties at nanoscale, as well as designing nano devices using nanomaterials. And also it is important to develop and construct tools for characterizing the synthesized nanomaterials. Without this technology to characterize, means when we design a nanomaterial, if we are unable to find its properties, then it's not going to help or serve. So it is also equally important to develop tools that will be able to characterize the properties of nanomaterials. So synthesis and design of nanomaterials are the essential aspect in the nanotechnology. And when we design these nanomaterials, we have we should be able to do we should be able to design and fabricate or synthesis at a desired size or with a desired morphology, chemical composition, crystal or microstructure. So when we get the desired uh, material, then only we can be used for the applications of then only we can have that for the applications of these materials. Nanotechnology is growing rapidly. The research and development is um, enhancing day by day, and it is growing rapidly. So, in the future, it is going to be one of the most premier science and technology for advancement. So, this is all about nanotechnology and its overview and its scope and its different applications and what you can expect. So, based on this video, you might have got an idea what to expect in nanotechnology, and so this hope this video will help you to understand whether pursue this field or not. So, it will. I hope this will help you to make a decision on this field. Thank you so much for watching this video. Please subscribe this channel to get more videos and click on the bell icon to get notifications whenever I upload a video. And do like this video and comment if you have any queries. And also don't forget to share with your friends. Once again, thank you so much.